Alright, today's lesson will be covering sine and cosine. I know that we talked about sine, cosine, and tangent, but we're just going to be discussing sine and cosine today. Alright, so as a refresher, remember that the sine will be opposite over hypotenuse, right here, opposite over hypotenuse, and cosine will be adjacent over hypotenuse. So if we were looking at angle A, okay, that's our theta. The side that's across from 90 is the hypotenuse. The side that touches angle A is my adjacent, and the side directly across from that is opposite. Okay? So here we have a problem with triangle XYZ, and we need to find sine of x, sine of y, cosine x, and cosine y. Alright, so what I'm going to do is I'm going to put over here sine x equals and sine y equals. I also want to look at the cosine of x, so I'll write that over here, and the cosine of y. So we need to pick one of the angles, either x or y. So let's start with x because it's the first before y in the alphabet. So this is the angle we're looking at. I know that the side directly across from 90 is going to be my hypotenuse, so that's 52. The side that touches angle x is my adjacent, and the side directly across from x is my opposite, 20. So I know that sine is opposite over hypotenuse, and I know cosine is adjacent over hypotenuse. So this would turn into 20 over 52, which as a fraction will simplify to 5 over 13. So that is sine of x, 5 over 13. Let me fix that, that way you can actually see that 13 didn't look right. There we go. And then cosine of x is adjacent over hypotenuse, so 48 over 52, which will simplify to 12 over 13. So now that we have solved the sine and cosine of x, we need to erase what we have, and this time we're looking at it from the angle's perspective for angle y. So across from 90 is the hypotenuse, so 52 is still my hypotenuse. The side that touches angle y is adjacent. The side directly opposite of that is 48. So sine being opposite over hypotenuse, this would be 48 over 52, which simplifies to 12 over 13. And cosine of y is adjacent over hypotenuse, so 20 over 52, which will simplify to 5 over 13. So what you'll notice here is that sine of x and cosine of y are exactly the same. Okay, and I also see that sine of y is equal to cosine of x. The reason that is because angle x and angle y are complementary. Remember that complementary means that they add to 90 degrees. So the sine of an angle and the cosine of its complement must be equal. Alright, so what I want you to do is take out your calculator. If you don't already have it out, pause the video and get it out. You will need it for this problem. Alright, so what you see here is a picture of the TI-30XS calculator. Okay, we are going to type sine of 48. This is just seeing, hey, can you type it in your calculator? So what you have to do is you have to look for a button that says sine. Let me get a brighter color that you can see it. So this button right here says sine. You're going to type sine, and then a parentheses will show up. It'll look like this. You now have to type in 48. So you type 48, close your parentheses, and then hit enter to calculate. So give that a shot, and we'll see if you get the right answer. Alright, the answer you should have received is 0.7431. Remember that you are rounding to 4 decimal places as instructed in the previous video. Now if you're getting something different, chances are your calculator's mode might have changed. You can easily fix this by going to the mode button and make sure you're set on degrees and not radians. If you're struggling with this, feel free to bring in your calculator and I will be glad to help you. Alright, so let's try cosine of 43. So we find cosine it'll bring up cosine with a parentheses, 43, and close your parentheses. What you should get here is 0.7314. Again, if you're having issues with your calculator, feel free to see me and I'll be happy to check your settings on your calculator. Alright, so now with trig, remember I said that Pythagorean theorem limited us from only being able to find one side given two others. Well, what happens if I only have one side and one angle? We can use trig to find the missing side. So, in this problem here, I have an angle measured 29 degrees. I want to label all three sides like I have done before. Label it opposite, adjacent, and hypotenuse. I always start with hypotenuse because it's the easiest for me. It's across from 90, so I label H for hypotenuse. I also know the side that touches the angle is adjacent, and the side directly across from that is opposite. Now you'll notice that there are no values or variables here at the opposite side. That means that we're not going to use opposite. We have adjacent and hypotenuse. So if we go back and look at our three trig ratios, I should put a theta there. If I go back and look at these three trig ratios, I notice that I don't have opposite and I can't use it. So that cancels out sine, I can't use that. And trig, I can't use that because I don't have the opposite. However, I do have the adjacent and the hypotenuse. So we are going to use this formula and plug it in. So I have cosine of theta, remember theta stands for the angle, so 29 degrees. Is equal to the adjacent over the hypotenuse. So what we're doing here is we are solving for x. Okay, remember when we talked about our similar triangles, we had proportions. We could think of this the same way as two fractions. We would cross multiply, so I get x times the cosine of 29 equals 18. Then, to get x by itself, I would divide both sides by the cosine of 29. So 18 divided by the cosine of 29. So what you're going to do is you're going to get your calculator out. And you're going to go back and hit this button, the n over d button right here. And you're going to make yourself a fraction with 18 on the top and cosine of 29 on the bottom. And what you should get is that you should get 20.6. I don't see any units, so that would just be our answer there. It's important to know the hypotenuse is the longest side. Therefore, 20.6 is bigger than 18. I'm on the right track. My answer makes sense. Okay? Now, let's do another problem. Okay, here we are given the angle of 42 degrees. We must label all the sides like we've done before. Across from 90 is my hypotenuse. The side that touches 42 is adjacent, and the side directly across from x is opposite. Notice that adjacent doesn't have either a number or a variable, so we are not going to use adjacent. So the only one that uses both opposite and hypotenuse is sine. And sine of theta is opposite over hypotenuse. So sine, theta stands for the angle, 42. The opposite is x, and the hypotenuse is 52. Now in this particular problem, the x is on the right hand side and it's above the fraction. So if x is being divided by 52, what should I do to get that off of the x? You're going to do the opposite, and you're going to multiply both sides by 52. So when you multiply both sides by 52, you get x equals 52 times the sine of 42. So then you're going to type this in your calculator and round to the nearest tenth as according to the directions, and you'll get 34.8. That makes sense because my hypotenuse is 52, so I know I have to be less than my hypotenuse, so 34.8 is great. Alright, now in this problem, we have both an x and a y variable that we need to solve for. Okay, so this angle is right here is what we're given. I'm going to label all the sides. Across from 90 is hypotenuse. The side that touches the angle is adjacent, and the side directly across from the angle is opposite. So I need to find both x and y. In order to find x, I have both the opposite and the hypotenuse, so I will use sine of theta. So the sine of 30 degrees is equal to the opposite over the hypotenuse. So I need to multiply both sides by 15, and it does not say where to round to, so we will just leave it in the radical form, or in the fraction form, excuse me, 15 halves. If you put 7.5 there, I would take that. Now to find y, we have adjacent and hypotenuse, so that would be cosine. So cosine of theta is adjacent over hypotenuse. So cosine of 30 equals y over 15. Multiply both sides by 15. And I get y equals 15 square roots of 3 over 2. Again, it did not say where to round to, so I would expect you to leave it in the fraction or leave it in the simplest radical form. Alright, here's the problem that I'd like you to try. Remember to start off by labeling all the sides, opposite, adjacent, and hypotenuse, and then setting up your equation. So pause the video and try this now. This is the angle we are given, 30 degrees. The side across from 90 is my hypotenuse, and the side across from 30 is opposite. The side that touches 30 is adjacent. I am looking for hypotenuse and given the opposite, so I will be using sine. So the sine of 30 equals 100 over h, or well, over d, excuse me, the hypotenuse. So what we need to do is cross multiply. Now here's how I remember. When x is up high, I multiply. When x is down low, you divide them, you know. So you see how catchy that is, right? Well, here's what you will do. I'm going to take d, and it will be equal to 100 over the sine of 30. So this is similar to the problem when we did here, when we had to cross multiply, and it ended up being that x and cosine of 29 switched places. That's going to happen in this problem as well. So I type that in my calculator, and I get that d equals 200 feet. Alright, why don't you try these two, pause the video, and then we can check our answers. Alright, so go ahead and take a minute, check your answers. On the first problem, you should have used sine because you are given the opposite side but looking for hypotenuse. Okay, when x is down low, you divide them, you know. And here you were given adjacent and hypotenuse, so you need to use cosine. X is up high, you're going to multiply, so it's 50 times the cosine of 15. Both of the questions I needed to round to the nearest tenth according to the directions, so you should have 8.4 and 48.3. Alright, that's it for sine and cosine. I will see you guys later.